Here we go, some notes on the trapezoid rule. This looks a little bit different than your pack. I was looking at your note pack, and obviously I was absent the day that the students did this, because this note pack that you have that looks kind of like this up at the top was designed for students to do without the direction of me, their teacher. So this year I'm actually going to teach it to you on the video. So your note pack does say that the College Board tests the concepts of the approximation of the area under a curve using right endpoint, R sub n, which we did, left endpoint, L sub n, midpoint, okay, which we did, and random interval approximations. That's from the charts where delta x changes based on the charts. And we've already studied all of those. We studied those in Unit 6 when I introduced the concept of an integral. There's one additional approximation method that the College Board expects you to understand and to execute, and that is the trapezoid rule for approximating an integral. So let's look at this function right here. We are going to approximate the integral from a to b of f of x dx using trapezoids, and we know that this means area under the curve. So let's go ahead and identify a and b, and we are going to divide this up into equal intervals. Okay, so in other words, delta x is going to be the same all the way across. Okay, this is going to be x sub 1 here. We'll label this x sub 2. B is x sub n. Of course, right before it, x sub n minus 1. And somewhere in the middle, x sub I. Okay, now in the past we used rectangles, okay, with equal width, and we got this formula by dividing b minus a divided by n, where n was the number of rectangles. Well, this time it's not number of rectangles, it's the number of trapezoids. Okay, and that b minus a over n is delta x, and that doesn't represent the width of the rectangle. It represents the height of the trapezoid. Okay, so right here, let me draw in the trapezoid that you would use. Let me highlight it in really darkly. Okay. Here's the trapezoid, one of the trapezoids that you would use to estimate the area. Here's the next one, right here. Here's the next trapezoid, okay? And these pieces right here, okay, this distance in here is that distance delta x. Okay, so the integral from a to b of f of x dx is approximately equal to the area under the curve, and we are using trapezoid rule to estimate it, and instead of r sub n we use t sub n, okay? And when you see that notation, that's going to mean trapezoid rule using n intervals. Okay, now we know that the area of a trapezoid is 1/2 base 1 plus base 2 times the height. Okay, so let's pull this trapezoid off of here right now. Here's that trapezoid kind of over here on the side, okay, but this piece right here is the height, and these two pieces, the parallel sides, are the bases. So that's going to be base 1 and that's going to be base 2 in this trapezoid right here, okay? So all these pieces right here are the bases, okay? All these pieces right here represent the bases of the trapezoids, okay? And each piece, each of those pieces is the base in 2 different trapezoids, because here is the next trapezoid that's right next to this one, okay? Here's the trapezoid that's next to it, okay? This would be B3. Sorry, I said this is the base. That's not the base. That's the height, okay? Okay, and this would be B3, okay, this base right here. And so you see that B2, this piece right here, is a base in 2 trapezoids, okay? And that happens with all of the bases except this first one. This first one right here is only a base in one of the trapezoids. It's a base in this trapezoid. And then this piece down here is also only a base in one of the trapezoids. It's a base in the last trapezoid. Okay, so if I'm going to find this area, I'm going to estimate it to be 1/2 the area of that first trapezoid. So 1/2 H times F of A plus F of X sub 1. That's this trapezoid right here. Now the trapezoid next to that is going to have an area of 1/2 H times F of X sub 1 plus F of X sub 1 plus F of X sub 2. Okay? Because that's how long these pieces are. These pieces go up to the curve, and if that curve is f of x, that's how long those pieces are. Then the next trapezoid is going to be 1/2 the height times f of x sub 2 plus f of x sub 3. And then we're going to keep doing that until we get to the last trapezoid right here, which is going to be 1/2 h times f of x sub n minus 1 plus f of x sub n, which is f of b. Okay? Now, what can we factor out of all of those? Well, we can factor out that 1/2 h, and I get f of a plus 2 f of x sub 1 plus 2 f of x sub 2 all the way to 2 f of x sub n minus 1 plus only 1 f sub b. Okay? And if I were to simplify that a little bit further, we get 1/2 delta x of f of a plus 2 f of x sub 1 plus 2 f of x sub 2 all the way down to 2 f of x sub n minus 1 plus f of b. All right, so this is the formula that you're going to use right here to find the estimate of the area under the curve using the trapezoid rule. So let's do one example. Okay, use the trapezoid rule to approximate the integral from 0 to 2 of x squared where n equals 4. Okay, so x squared is that parabola. 0 to 2. There's 1 right there, right in the middle. N equals 4, so each piece is, interval is 1/2. Okay, so 1/2, 1, 3/2, and 2. And let's go and find the area of this trapezoid. So it's going to be 1/2. Delta x is 1/2, okay, because delta x is 2 minus 0 over 4, which is 1/2. So delta x is 1/2 times all f of a. Well, f of a would be f of 0 plus 2 times f of 1/2 plus 2 times f of 1 plus 2 times f of 3/2 plus f of 2. Okay, so this is a right here, f of a, this is b right here, and then all the other intervals in between have a 2 with them. Okay, so that's going to be 1/4. F of 0 is 0. If I put 1/2 in there, I get 1/4, so 2 times 1/4. If I put 1 in here, I get 1, so that's 2 times 1. If I put 3/2 in there, I get 9/4, so 2 times 9/4. And if I put 2 in there, I get 4. Okay, so let's add those all up together. So that's 2/4 plus 8/4 plus 18/4 plus 16/4. Okay, so that's 10, 28, 44/4. So that's going to be equal to 1/4 times 44/4, which looks like 11/4. Okay, and so that's my final answer. Okay, so that's the end of the notes. We will have some problems to practice. You can work on those in class the next time we're together. And I will see you soon. Bye.